Statistics 3, central limit theorem. Type 1, standard error of the mean. A, find the probability. So here in this question we're given a random sample of 250 is selected from a population having a mean of 30 and a standard deviation of 5. Find the probability that the sample mean is greater than 30.5. So if we look at the information given to us here, we can see that n, our sample size, is 250. So this means that n is greater than or equal to 30, and therefore our sampling distribution must be normal, regardless of what the underlying population is. We know that our sampling distribution isn't going to be normally distributed. So therefore that means our central limit theorem comes into play, and we have our mean is 30. Our standard deviation is equal to 5. We're told that our sample mean is going to be, we have to find the probability that the sample mean is greater than 30.5. Okay, so therefore we're going to be using our standard error of the mean formula, which is on page 35 of our maths tables. So in other words, the standard error of the mean is our z-score as we know it of old, but of course this is going to be adapted because we're looking at a sample. So it's going to be the sample mean minus the true population mean over sigma over root n. In other words, the new standard deviation. So we're using this because our central limit theorem comes into play here. So therefore, if I get z, well, that's going to be 30.5 minus the population mean over the standard deviation divided by the square root of n, which is 250. So that gives us a z-score then of approximately 1.58. We take it corrected 2 decimal places. So now we have our z-score. Well, what we can do is find the probability that the sample mean is greater than 30.5. So if I go on to the next page, what this is basically asking us to do is to find the probability that the sample mean is greater than 30.5. Now, of course, we know from our normal distribution tables we can't actually use the value for our variable x. So we have to adjust that and change it into our z-score. So because we're looking at samples, it's not the z-score that we're changing it to, it's the standard error of the mean that we're changing it to. So we worked out that z was going to be approximately 1.58. So therefore we need to find the probability that z is going to be greater than 1.58. So we know from our normal distribution questions that you were working with the last day, that the first thing we always do is sketch our graph, and we look at a z-score of 1.58. So z-score right in the middle is always 0. So 1.58 is approximately here. And greater than 1.58 means to the right of that. So we're looking for what area is represented by this shaded area. In other words, what is the probability that it lies within that value there. Now we know, of course, that we can't get greater than on our normal distribution tables. Instead, what we have to do is find 1 minus less than all of that. So in other words, if I just shade in, let's say in green, everything that is less than 1.58 there can be found using my normal distribution tables. But of course I don't want the green area, I want the red area, and the green and the red together makes 1. So therefore if I get 1 minus the green area, which is the probability that z is less than 1.58, then I can get the red area. So let's write that down. Well, probability that z is greater than 1.58 is the same as getting 1 minus the probability that z is less than or equal to 1.58. Okay, so if I go to my tables and I locate 1.58, then I find that that is 0.9429, and therefore that gives me a value of 0.0571, which is what we're looking for. So what this means is that the probability that the mean that the sample mean is greater than 30.5 is 0.0571. So that's quite a low probability, okay? So just as a reminder, from your tables, we go down to 1.5 and we go across to 0.8. So that brings us across and down. And there we have our 0.9429, okay?